In this video, our objective is to make a line forward board using digital ICs and using 4 IR sensors. And now let's begin move towards the introduction of this video. And basically, in this video, we build a line forward board using digital ICs and using a IR sensor, and we will also use a gate driver IC L298N, and we also use some other components. So if you want to learn efficiently, then you need to then you just need to watch this full video, and if you want to learn efficiently, do not skip this video and follow this video step by step. Now I move towards the block diagram of this project. Here you can see I connect IR sensor 1, IR sensor 2, IR sensor 3 and IR sensor 4, and here you can see it is a logical circuit means here we build a logical circuit using gates IC, using gate ICs, and here we just build a control circuit, and here you can see here is a motor driver, and here we connect left motor, and here we connect a right motor. So it's our complete diagram of our project, and next I will explain the truth table of this control circuit of line forward board, and here next I explain the truth table of this control circuit, and here you can see some abbreviation that we use in our truth table. Here you can see R is equal to right, it means the position of right IR sensor, and here you can see L mean left sensor mean position of left sensor, and here you can see center right mean CR is equal to center right, basically it is a position of center right sensor, and here next you can see it is center left. So here you can see basically it is the position of a left sensor. Here we move towards the truth table, but you just need to remember these abbreviation, and here you can see MR is equal to right motor and ML is equal to motor left, it means left motor. Now move towards the truth table of this circuit. Here you can see when we didn't have any input at the IR sensor, then the output is absolutely 0. Here you can see right motor is off, 0 mean off, and left motor is off. And next you can see when our right sensor, left sensor and center right is off, and then center left is on, then our right motor will be on, and left motor will be off. Right motor is on and left motor is off, it means the line forward board move towards left position. So next here you can see right left motor is off, and here you can see center right motor is our center right sensor have input, and center left sensor didn't have any input. So in this case our right motor and left motor will go through state condition. It means that both motor is in on state condition, and our line forward board will move forward. And similarly next you can see when our center right and center left sensor is on, then our both motor will be on, and our line forward board is remain in forward mode. So here you can see next when our left sensor is on, then our right motor will be on, and and left motor will be off. It means the board will turn left. And next here you can see it is our don't care condition. And next here you can see when our left sensor, center right and center left sensor is in on mode, then our right motor is on and left motor is off. Then similarly the same condition. And in this truth table basically we use artificial intelligence control system. So on that basis we make this logical truth table. And here you can see when our right sensor is on, then our left motor will be on. It mean right motor is off, left motor is on. It mean the boat will move towards right position. And next here you can see similarly when our right sensor and center left sensor is in on mode, then at the output position it have a don't care condition. So here you can see next when our right sensor and center right sensor is on, then our left motor is in on mode. It means that the motor move towards the right position. Similarly for the next condition, and next here you can see don't care condition. And next here you can see our right motor is on and it move towards the left. And here you can see it is the basically it is a position of sensor. The sensor at a time the random sensor will be on and off, in on and in off position. So here you can see in the next condition output, here you can see 1 and 0. 1 and 0 mean 0 0. Here right motor is off, left motor is on. It means the motor move towards the right position. When we have all 1 1 input at the IR sensor, then we have both 1 1 position. It means that our motor our boat will move forward. And here you can see it is the output of the right motor. And here you can see it is the output of the left motor. And next we will build a K-map for these outputs. And here you can see basically it is a 4 variable K-map. And here you can see it is the K-map for the right motor. And here I find out this, and here I find out this equation at the output. Here you can see. And so we build our circuit according to this equation. We make this hardware circuit or logical circuit in Proteus according to this equation for right motor. And next here you can see K-map for left motor. And here you can see I put all the output value of the left motor that we find. And here you can see here I find the value output equation for left motor. So we will design our circuit according to this equation for a left motor. And next I will explain in front of you the component explanation of this circuit. And here you can see we use here logic gates. According to our equation we only use AND gate, OR gate and NOT gate. So according to the equation, here you can see the input. Here you can see the AND gate IC. Here you can see 4 AND gate is integrated in this IC. And here you can see basically 1 2 is input, and 3 is output of this AND gate. And here you can see similarly the input and output, input to input, and one output. Here you can see pin number 7 is the ground pin of IC, and pin number 14 is a VCC pin of the IC. And here you can see similarly the configuration of OR gate IC is similar to AND gate IC. Here you can see 1 2 is input and 3 is output, 4 5 is input and 6 is output, and 7 is ground pin, and here you can see VCC. 14 number pin is a supply pin of the IC, and here you can see 12 and 13 pin of the AND gate, and 11 number pin is output of this AND gate, and here you can see similarly. And here you can see the NOT gate IC. Here you can see basically NOT gate have only one input and one output. Here you can see pin number 1 is input, pin number 2 is output, pin number 3 is input, pin number 4 is output. Here you can see 6 NOT gate is integrated in this IC. And next, here you can see IR sensor. Basically IR sensor is a device that detect the infrared radiation from the environment or from its surrounding. Here you can see basically it is the it emit and receive the infrared radiation. According to this mechanism, IR sensor is work. And here you can see the picture of IR sensor. Here you can see, and next here you can see gate driver IC. Here I use L298 and gate driver IC that is used to drive the rotation and for direction of motors. And basically it have a several number of pins of input and output, and some pins of control. And here you can see in 1 and in 2. Basically these pin for motor A, these pin are used to control the direction of motor A, and 2 motors capability. Basically we can drive 2 motor from this gate driver IC. And here you can see in 3 and in 4, basically these from these pin we can control the motor B using these pins. And next here you can see enable PWM signal for motor A, and next here you can see enable PWM signal for motor B. And next here you can see output 1 and output 2, output pin for motor A, and here you can see output pin number 3 and 4, output pin for motor B. And here you can see the L298 IC have input pin that is 12 volt, and here you can see the input pin is a 5 volt. Here you can see clearly basically it is 12 volt pin, ground pin, 5 volt pin, and motor A, motor. Here we connect motor A, here we connect motor B, and here you can see enable B, enable A, input 1, input 2, input 3, and input 4. All these pin, from all these pin we can control the rotation and direction of the 2 motors. And next here you can see DC motor. We use DC motor to drive the line follower robot. Basically DC motor is a motor that take a direct current and convert it into a mechanical energy. It means that it convert into a rotation. So basically the mechanism of DC motor working is basically we produce the magnetization in the winding of DC motor, and when magnetization is produced and it react with the rotor, and according to this mechanism our DC motor move. And next The next very important step is here I implement the circuit in Proteus according to my Karna map equations. Here you can see I connect four IR sensors. Here I connect four IR sensors, and here you can see I connect the logic gates. Here you can see I connect and not or logic gates according to my equation that I taken out from corner map. Here you can see I implement the circuit according to these equations. Here you can see these two equations, this equation for motor right and this equation for motor left. And at the output, here you can see here is a gate driver IC L298 and gate driver IC, it is a right motor, it is a left motor. And now it's time to verify this Proteus circuit, and now it's time to verify this Proteus logical circuit. And now here you can see the truth table of this control circuit. Here you can see when we give 0 0, then the output will be 0 0, motor right 0, motor left 0. And next, here you can see, for example, here we take one random input. Here you can see here we can see 0 1 0 1. Zero, zero, one, zero, one. And just run this circuit. Just zoom out. See the motor output 0 1 0 1. The right motor is in on state, the left motor will be in off state. It means that the motor will rotate towards the left, and it means that 0 1 0 1 right motor will be on. And here you can see the right motor speed is 200 rpm, and here you can see it is 3.1 rpm. It means it is approximately is equal to 0. It is approximately equal to 0. And here you can see its speed is 270 rpm, and it's varying speed. And next, this motor speed is 0, and this motor speed is good speed, approximately 300 rpm. It is 2.2, it is approximately 0. And next we verify another state 1000. Just zoom in this circuit. What is 1000? 1000. Oh, one motor is on. Left motor. Here you can see this motor speed is moved towards reducing, and here you can see, sorry, here you can see right motor speed is reducing towards 0, and here you can see this motor speed is increasing. It means that left motor is on state and right motor will be going to an off state, and the line follower robot turn towards the right. And next, here you can see 1000 output is motor right is 0, motor left is 1. Here you can see motor right is speed is 259 and is increasing, and here you can see sorry, motor left speed is increasing approximately 280 rpm, and here you can see motor right speed is reducing, moving towards 0, and here you can see motor left speed is just increasing and increasing according to its capacity. And similarly you can verify the all logic states according to this truth table. And next I will show you the hardware of this circuit.